All right, so like I said, we're going to start with an easy function. So let's go to y equal to, let's do an easy one. Let's say x squared. Let's go ahead and put x squared. Do you see my mouse moving around? X squared, we'll say plus 3x minus, what should we say, 5? I have no idea. And press enter. Alright, so this is it. Alright, before we graph this, you should be able to see this in your head. Can you visualize this function? What does it look like? It is a parabola. It's a curve. It is opening up or opening down? Up. Okay, so let's go ahead and press graph. And there it is, right there. Beautiful. Alright, so you should have this. Okay, how many of you guys got this on your graphing calculator? Alright, like I said, we're just playing around with it. Make sure you know how to graph your function on your graphing calculator. If you're having a hard time, you might want to ask your neighbor. Alright, we're just playing around with your graphing calculator, that's it. Alright, so our goal is to find this x-intercept right here. Later on, we need to know how to find this x-intercept. And do you see this vertex at the bottom right here? This is your vertex. We call it a minimum because it's at the bottom. Okay, but this is your vertex. Alright, anybody know how to find this x-intercept right here? We have two of them. We have one on this side and we have another one on the other side. Anybody know how to find this x-intercept? Yeah?
Quadratic formula.
You can use a quadratic formula, but we want to use a graphing calculator. So for that one, we want to use trace. On top of trace, it says calc. So you want to press second, and then calc, which is trace. It will say 0. 0 will help you to find the x-intercept. So go down to 0 and press enter. And do you see this little bug blinking back and forth? If you press left arrow, it says left bound. Do you see that? Direction says left bound and question mark. You want to be on the left side of this x-intercept. So you want to be around here someplace. So you move it till you get there. It doesn't matter, as long as it is on the left side of it. So you could be this high or even higher, it doesn't matter. All right, so make sure your little bug is right there. And then press enter. And the next direction will say right bound. So you press right arrow. And again, as long as it is on the right side of that x-intercept. Looks like this is on the right side. And then press enter. And it will say yes and press enter for that one. It will tell you the 0. So your 0 is at where, approximately? Negative 4.1925 and so on. That will be your 0. One of them. All right. So can you find this 0? All right. Play around with your calculator, and I want you to find the other 0. All right. Find the other 0. Go ahead and do that. You need to learn how to use your graphing calculator. I told you, your EP exam, you must know how to use your graphing calculator. It's a must. Okay? Yeah. Graphing calculator is part of your AP exam. Oh, okay. All right. Did anyone found the other 0? Anybody have the approximation for the other 0? Yeah, what is it?
1.19258.
Alright, so 1.192 something something. 1.19. Okay, how many of you guys got 1.19? Raise your hand. Okay, very good. Now, sometimes you can just press trace, and then that little bug will go around that curve. Do you see it? and then you can move it so that it is close to that area. But this is not 1.19, and this is not 1.19. Do you see that? It gives you a pretty good approximation, but it does not give you the actual zero. So on the AP exam, if they ask you to find the zero, you need to use the zero feature on your graphing calculator. Are we clear? Okay. Next, we want to find this vertex right here, minimum. So how do we find this minimum point down here? So same thing. You go to second, trace, which is calc. This time, you need to know if it is a minimum or a maximum. So we said it was a minimum, right? So you go down to minimum, press enter, same direction. It says left bound of this minimum point, so you need to move it. All right, as long as you're on the left side of the minimum point, it could be anywhere. So this is close enough. This is on the left side, press enter. And then right bound, right side of it. As long as it's on the right side, that's good enough. And then guess, it'll give you the minimum point. Alright, so there it is. I can probably guess like 1.499999 is what number? 1.5, yeah, right? Does that make sense? So most likely it will be 1.5 and negative 7.25 will be your vertex, minimum vertex. Okay, very good. Now, we did a parabola, which is very simple, but we need to look at some rational functions. All right, so that means you have a fractional function. Okay, so let's see. Do you guys know how to put fractions with your calculator? How do you put fractions with your calculator?
You hit alpha and then you go to y equals, right?
Oh, okay. So go to math. Go to math, and then do you see this fraction on the very right corner? Move the arrow to there, fraction, and do you see this n over d? This stands for numerator over denominator, press that, and then you get a fraction bar like that. Okay, now if you have the older calculator, I don't know if you have that feature or not, but it really depends on what type of calculator you have. All right, so let's do one. Let's put x plus 1, and down arrow. Let's put x squared minus 3x plus 1. Alright, so I'll wait for you to get here. Make sure you have a fraction bar and all that stuff. Alright, so from your delta math, they're going to give you a complicated rational function. Do you know how to visualize this without your graphing calculator? Can you do it? Well, if you can, then that'll be great, but most likely you'll say no, right? So what does that mean? We need to use our graphing calculator to graph. Does that make sense? Okay, so go ahead and graph, and we get something like this. My computer is a little bit slow, so. Okay, so this is where it gets more complicated. You see that we started with a parabola. Parabola was pretty easy to follow. Not only we need to look at the x-intercept, not today, we don't really need to look at the x-intercept, but we need to look at end behavior. All right, so I know that some of you guys studied end behavior before. on a second. My computer is just slow. Hold on. We'll get there. Seriously? Okay, here it is. Okay, so as I go out this way, as we go to the right, do you see the blue curve? What number does it go to? As I go to the right, anybody have an idea what number this blue curve will go to? It's not infinity. Someone said it. It is 0. The answer is 0. How many of you guys see that? Raise your hand. That's your end behavior. You need to see it. Okay? Alright. As I go towards left, do you see the blue curve? What number does it go to? 0. Very good. In calculus, there is a notation for this. So instead of putting arrow and 0, we say as x goes to the right means positive infinity, or just infinity, which is positive infinity. F of x will go to 0. This notation is same thing as what I just said here on the top. Do you agree?
Yeah.
In calculus, we say it like this. Limit as x goes to what? Infinity, f of x is equal to 0. This statement, this notation, is basically saying this and this one. I hope you guys are clear. So how do you use calculus notation for this part right here? What would it be? As limit as x goes to negative infinity, f of x goes to 0. Alright, that was the easy part. The hard part is sometimes your number will go to here, right here. I'm going to put a little tick mark. I'm going to say this is 0.5. Okay? At 0.5. You see it? Just pay attention. What happens if I go as limit x goes to 0.5 from the negative side, f of x? Alright, what does it mean by this notation? You're coming from which side? Do you remember? From the left side. If I'm coming from the left side here, and I get closer to 0.5, what is your value? Positive what? Infinity. Very good. This is positive infinity. How many of you guys see that? Okay, so what if I change this? What if this one is limit as x is approaching to 0.5 from the positive side? Alright, you're coming from the positive side, from here. What is your limit value? Someone said it. Negative infinity. Alright, so it looks like there's a vertical asymptote line at negative 0.5. Do you see that? And then this is how we describe your vertical asymptote in calculus. You need to know that this notation basically means you have a vertical asymptote there. Look, we have another one right here someplace. We'll say this is at 3. Alright, so let me erase this. If I can erase it. Okay. Alright, so let me write it down here. As limit goes to 3 from the left side, f of x, what happens? From the left side to 3, from left side, what happens?
Negative infinity.
Negative infinity. And then from the right side, positive infinity. Alright, so I'm hoping that you feel somewhat comfortable with graphing these things. You know that you can zoom in and zoom out and so on, right? There's a zoom button with zoom in and zoom out. Okay, so let's go ahead and sign into your Delta Math. Alright, so pay attention please. Let's do another one. Okay, here we go. Alright, so when you look at this, I want you to just, this is given to you already, okay? We're looking for asymptotes, horizontal asymptote, vertical asymptotes, and so on. Does anyone see a vertical asymptote? Yeah, how many do you see? 2. One of them at -2, and other one at 5. Okay, let me make it a little bit bigger. Can you guys see it better? Alright, do you see a horizontal asymptote?
Yeah.
Okay, one of them is close to where? 3, and the other one is at -2. Okay, very good. So in total, how many asymptotes do you have in total? 4. So there are a total of 4 vertical and horizontal asymptotes. There is a horizontal asymptote. Y is equal to where? 3. Okay, because, remember the notation. 3 because as x approaches to which one? Really? Yeah, you're going this way, isn't it? So as x is approaching to positive infinity, it goes to 3. There it is. Do you see that notation, calculus notation? All right. There is the other horizontal asymptote at -2. Which one? Negative infinity, because you're going towards negative side, right? Negative infinity. All right, there's the notation right here. It's a negative infinity means left. And there is a vertical asymptote. Where's the vertical asymptote? At -2. Because as what? As we approach to -2, which way is it? As we approach to -2, which way does it go? Alright, so -2 goes to negative infinity. Do you see that? And the last one is at 5, vertical asymptote at, oops, sorry, this is vertical asymptote at 5, because as you approach to 5, what happens? Is it positive infinity or negative infinity? Negative infinity. Alright, how many of you guys are able to follow what I just said? Alright, excellent. You guys are so smart. Okay, good. Alright, so basically that's what we're doing. Now, this was all given to you. Do you see that graph was given to you? Sometimes it's not. So take a look at something like this. Alright, this graph is not given. So do you know the answer just by looking at it? How many of you guys know the answer just by looking at it? I know the answer just by looking at it. Anybody know the answer to this? It is 21 over 18, which should be reduced. That is your limit. It is 21 over 18. If you don't see it, then you need to graph it out. But you only need to look at the highest power from each one. So what is the highest power on the top? This one right here, isn't it? Oh shoot. It's this one. I'm so dumb. I need to stop recording this and then don't be laughing. No laughing. I'm kidding, guys. I make mistakes all the time. Alright, so we're looking at this one. That's the highest power. And this is the other highest power. You just need to look at those. And you cancel out. So basically you have negative 9x to the fourth over negative 4x to the fourth, and you cancel out the x to the fourth and x to the fourth. Cancel out the negative and negative. So the answer to this one is just 9 over 4 will be your answer. Okay, how many of you guys follow what I just said? Okay, now if they're different, you have to be careful. Okay? So let me clear this. But you can use your graphing calculator. Look at this. What's the highest power that you have on the top? 3. What's the highest power on the denominator? 4. You can cancel, and you can cancel this, but how many x do you have left over? 1. So it's basically, it is 12 over x. Does that make sense? So you need to know what this thing is. Is it infinity? Is it 12? Is it 0? Well, how do I know? This x stands for as, do you see this part right here, this notation? X is getting close to what value? Infinity. So this means 12 over infinity. 12 over infinity. All right, so what do you think? What is 12 over infinity? Anybody have an idea what 12 over infinity might be? 12 over very big number. What do you think? Put it into your calculator. 12 over like a billion. I don't know. What is 12 over billion or trillion or quadrillion or giga, whatever? What is it? It is close to what value? 0. This is close to 0. The number down here is so big that it will be close to 0. The answer to this will be 0. What do you think it happens if you have an x on the top and if you have a number at the bottom like this? What if it was switched? What do you think will happen? Is this 0? Or is this infinity? Or is this 12 over 3? This will be infinity. Infinity, because this is 12 times infinity is even bigger number, over 3. Does that make sense? Which is a very big number, which is infinity. However, like you said, infinity is actually d and e, because infinity doesn't have a distinct value. Okay? So that you will put d and e for that. Oops. All right, so that's your, but you can actually graph this out with your graphing calculator. It will show you towards, as you go to the right, it will tell you where it goes to. Like your function will go to some value. You can tell. All right, a shortcut is using those things right here. All right, so let's go back. All right, basically this is the same thing as well too. So go ahead and graph. This time let's use a graph, okay? Can you guys graph this using your graphing calculator? Let's see if you guys know how to graph this using your graphing calculator. Alright. And it's telling you to look only on the left side. You need to go towards left side. How did I know that we're supposed to go to the left side? It says x is getting close to what? Negative infinity. That means we're going towards negative side, which is left side. Alright, show me your graph once you have this, okay? Alright, anybody, if you have a graph, show it to me. Anybody have a graph?
I got error.
You got it. Oh, you shouldn't get an error. Alright, so learn how to graph this correctly. Anybody have a graph? Alright, so you have something like this. Is that what you have?
Yeah.
Something like that? Alright, can someone tell me what this thing is getting close to as you go towards this way? I don't think it's 0. Look at it really carefully. It's getting close to 0, but it's not 0. I think it's supposed to be 1/2. Alright, does it look like it's at 1/2? And again, how did I know? Because of this right here. Do you see that? Do you see the shortcut? X squared and x squared goes away. 2/4 will be 1/2. But you can tell with your graphing calculator. Does that make sense? Alright, so that's what we're supposed to do. Okay. Alright, I'm going to skip the horizontal asymptote. I'm hoping you know how to figure this out. This piecewise function is very important. You need to know how to graph your piecewise function. Okay, so let's go ahead and you need to graph both of them on your graphing calculator. First, go ahead and graph -4 plus 2x squared. What type of graph is that? Anybody have an idea before using it on your graphing calculator? It is a parabola that is opening up. Okay, go ahead and graph it. Did you graph it?
Yeah.
Okay, let me see. So, do you have a parabola like this? Okay, is that good? Okay, so far so good, right? I'm going to use a blue one now. You can use whatever color you have on your graphing calculator. Go ahead and graph this part. Before you graph this, you should know what type of graph we're going to get with this function. Anybody have an idea? It is a linear line. It is a line. Alright, anybody have a graph of that? Yeah, so it kind of looks like this. Do you get something like that? Close enough? Okay, now for a piecewise function, we do not keep all of them. Let's start with red. Concentrate on my red color. This parabola. I need to erase certain part. Do you know where I need to erase this parabola from? What number do you erase parabola from? What number? Anybody have an idea? It's at 1. So go to 1 over here and find the parabola. I think 1 is down here someplace, isn't it? Is it down here someplace? Is it open circle or is it a closed circle? This is open circle. Why is this open? Because of this. You guys know that strictly less than or greater than is open. I hope you guys know that. Alright, which part do I need to erase? Do I erase the right side of this open circle or the left side of this open circle? Which part do I erase? I need to erase the right side. This one. All of these things should be crossed out. How do I know? How do I know that I'm supposed to cross out all this stuff? This one says x is less than 1. Less than 1 is everything on the left side of that. How many of you guys understood what I just said? Okay. Alright, what about this one in blue? What is that? It's the blue color at 1. It's supposed to be over here someplace. Is it open or closed? Open. It is open again. Alright, so do I erase the right side of this open circle or do I erase the left side of this open circle? Left side. I erase all of this. Does that make sense? So if you clear everything, take me forever to do this. But I think you get the point, right? So you get this blue curve. Blue line. And this red one. That is your piecewise function. Okay, so think about it. What is the meaning of, alright, now take a look at this meaning. It doesn't have plus side or the negative side. What's the meaning of x is approaching to 1? From both sides. From both sides. If I approach from the left side, what is your value down here, approximately? Can someone tell me? Look at your graph. Approximately, if I'm approaching to 1, from the left side, what is this y value?
Negative 4.
Like negative 4?
Yeah.
Okay, like negative 4, it might be. If I'm approaching from the right side, can you tell me the blue value? To 1, approximately. It just has to be close. 0? So from the left side and the right side, are they matching? Are they matching? No. So what does that say? Your limit is then what if they do not match? E and E does not exist. Your limit does not exist. Alright, these are all graph. I'm going to post this, okay, so you guys can look at it. I'm recording this right now, okay? So you can replay the video if you like. But eventually, we want to get out of graphing calculator because this is tedious. Isn't this quite long? We don't have 5-10 minutes to graph and then analyze. We need to come up with answers like this. So for you to do that, you need to develop your algebraic skills, which we're going to start doing tomorrow. Okay? But the last part is actually factoring. See if you can figure that out on your own. Alright, so go ahead and work on your delta math, and I'll post this video